Now let's turn to page 108 and do the question 32 here. So it's a schematic diagram showing a reactor to produce like the titanium from titanium 4 chloride, right? So firstly, if you see those words, it's a bit hard to process, right? The first step we do here is to try to turn everything into chemical formula. For example, here is like sodium, titanium, chloride. If you don't know how to do this or the cross method, you can take a look at the question A, right? It's already listing the chemical formula for you, but I'll do this for this time in case some of you still don't know how to do the cross method. So titanium, it's like IV means 4, right? We have 4 plus here, and chloride will be minus. And if we do the cross method, 1 goes here, 4 goes here. The chemical formula will be TiCl4, right? Similarly, here is SaNaTiCl4. Argon is like a noble gas, this one. So if you can see it, this is actually belong to your group 0, or you can call it either group 8. Titanium is Ti, and sodium chloride will be NaCl, right? So the first question is asking us to balance the equation. So let me copy the equation here. Alright, let's count. How many numbers of titanium on the left? They have 1, right? This one also has 1, so we don't need to do it. And then let's take like how many chloride here? We have 4 on the left, but we only have 1 on the right. So we put a number 4 in front of it, right? And then let's take like a sodium. We have like, remember the rainbow method? Now we have 4 sodium here, right? But we only have 1 on the left, so we have to put another 4 here, right? Is it balanced now? Yeah, if you check it, it should be balanced. Alright, then let's take a look at, this one is question number A1, right? Now let's take like question number A2. So, as what does the reaction suggest about the reactivity of titanium compared to that of sodium? Remember, this one is very similar to the displacement reactions, right? So here's like, titanium originally it's in, I'll write the states at first. This one is aqueous, solid, and also aqueous, right? So originally, titanium is in aqueous form, but now it becomes in the single solid, and the sodium has been go into the solution forms, right? If you remember the displacement reaction, that will have using like more reactive metal to displace or to replace less reactive metal out, right? So this one, comparing these two, which one here should be the more reactive metals? This one should be sodium here, right? And then the less reactive metal is the one that bonds with the chloride and in aqueous form. This one should be titanium. So here, we can write that titanium is less reactive than sodium. This is the answer for A2. Now let's take a look at B. It says, suggest why the reaction is done in an atmosphere of dry argon instead of air containing water vapor. So firstly, as I just said, argon is a noble gas, right? What does it mean by noble? Alright, first, argon is a noble gas, which means it is relatively unreactive to the reactant here. And also remember, it says that, containing water vapor. Let me remind you which metal here can react with cold water. We probably didn't study titanium, but what about sodium? Can sodium react with cold water? So remember, we have this formula, right? So it will form a sodium hydroxide and also hydrogen here. Is it balanced now? So the water vapor, this is the first point that you will get 1 mark. The second point is the water vapor would react with sodium. So that means that's the reason why we cannot use the air that contains the water vapor, right? So if you answer these 2 questions, then it will get 2 marks for that. Alright, let's take a look at number C here. It now comes to our calculation. It says in one reaction, the number is kg. It's very big. So let me copy the balanced equation first. Duplicate and then move it to here. Interesting. I don't have T. Right. So now this is our balanced equation, and in the reaction here, it gives us 163 kilogram of titanium chloride react with 0.0 kilograms of sodium. Remember, if it given you 2 mass, then you have to determine which one should I calculate, right? The first step, we should be able to identify which one should be our limiting reagent. Okay, now let's try to calculate the moles first. If we want to get the limiting reagent, the first thing is to know the ratio to coefficient, right? Oh, I forgot about one part here. Right here, ratio to coefficient. Remember, for coefficient, it is actually equals to our mole ratio here, right? If we take a look at the mole ratios, this one should be 1, this one should be 4. Now we put a 1 to 4 here. Now let's try to calculate the moles for those 2 masses. And we should have known that most importantly, we'll have to know the molar mass, right? The molar mass of titanium chloride, it should be 47.9 plus 35.5 times 4. You can also type it in your calculator, 189.9 grams per mole, right? Remember, here's grams per mole, and let's take a look at the sodium here. Sodium here should simply be 23.0 grams per mole, right? And then, if you take a look at the units, are these units the same? They're not, right? So firstly, we should convert it into grams. So you have 163 times 10 to the power 3 grams, right? I won't just write it, so I simply use a scientific notation to represent that. Which means this times by 100, this part equals to 100. Alright, now I know the grams, I know the molar mass, I should be able to calculate the mole, right? This one should be 163,000 grams divided by 189.9 gram per mole. What should be the answer? This one is 858.3 moles. Similarly here, it will be 1,000 grams divided by 23.0 gram per mole. The answer here is 3,521.7 moles, right? So, and then let's do the ratio to coefficient. This one will be 858.3 mole divided by 1 mole, right? Here's still this answer. And if we try to do the ratio to coefficient here, it will be 3,521.7 mole divided by 4. Let me move this to here. So the answer here should be 880.4 mole, right? So comparing these two, which one is smaller, which one is bigger? It has to be this one, right? So now we know that the TiCl4, this compound, will be our limiting reagent here. I'll use Lr to represent limiting reagent. Remember, only use limiting reagent. So please write a sentence on your worksheet. Only use limiting reagent to calculate. This is a very important sentence because this one is in excess. It's similar to the one that I explained before in question 32, right? Alright, now we know which one is a limiting reagent. What does the question ask about? Calculate the mass of titanium produced. Can we calculate the mass of titanium produced this time? How about I move it a little bit there? Can I? It will be out then. Probably here, yeah. So let's find the molar mass for titanium. Let's find the moles first. All right. We have already determined the limiting reagent, so I will just like erase all of them out. Then this will be easier for us to understand how can we calculate titanium here. So let's take a look at the mole ratio. Take a look at here. So let's take a look at the mole ratio for titanium chloride and titanium. The ratio here should be also 1, right? So we know that the ratio here is 1 to 1. And we know that the mole, if the ratio is 1 to 1, like remember for the ratio, it will always put the one that we unknow at the top, another ratio at bottom, right? So we'll have exactly the same number of moles of titanium here. And then let's take a look at the molar mass for titanium. From the question, it should be 47.9 gram per mole, right? If we have this, can we calculate the mass for titanium? Remember, mass equals to mole times molar mass, right? So now here we use 47.9 times 858.3. So if we times it all together, the mass will be 4,111. Oh no, it's 41112.6 grams. So what does the question ask about? Is it necessary to change it to kg? Oh, it doesn't ask about how many kilograms, so you can keep it in this way, or you can also write it in 41.1 kg. It might be better because 3 significant figures. 3 significant figures. Yeah. This one will have 1, 2, 3, 4, 5, 6 significant figures. It will be better for us to write in the kg form. So this will be the answer for part C.